Alright guys, so today we're going to be going over the instructions for the limiting reagent lab. It's a very simple lab, not a lot of stuff to do, but it's very important that you guys keep a couple things in mind. So the first important things are the two lab safety rules. So for this lab, you don't need to wear goggles, but the first thing that's very important is that since we're not wearing goggles, that you guys aren't messing around, that we don't spill any liquids, that we make sure that everything is under control and we're taking care of the equipment and keeping an eye on the chemicals. The second important safety rule is that you don't break any of the equipment. We'll talk about that more in detail coming up, but there are a couple portions in the lab where we do have to be very careful, especially working with the glassware. And so just make sure that every moment of the lab when you're working with the glassware that you're aware of where it is. Make sure that you don't have this glassware close to the edge of the table where you can knock it off. Make sure everything is in the middle of the lab station, that everything's under control, even when you're moving stuff around, that you know where everything is in relation to your body and you just keep track of everything. Also keep in mind that if you do break anything during this lab, since it is such a simple lab, that you will get an automatic 0 on the lab and that you will get some bans for future labs. Just make sure you guys keep that in mind, that everything is careful. What you're going to be doing in and of itself is very easy, and there should be really no reason for anything to get broken. So when you get to your lab station, you should see a setup just like this, where you have a 250 milliliter beaker, you have a funnel, you have a stirring rod, and you have a 250 milliliter Erlenmeyer flask. And so these are the four pieces of the equipment that you'll find at your lab station. And the group that had your station previously should have cleaned it up and left everything like this. And if you don't have anything, please let me know and we'll take care of that. What we're going to be working with first is a 250 milliliter beaker. So let's kind of put that to the side right here. And so for the beaker, we're going to be finding the mass of the beaker. So you're going to take this to the scale and you're going to find the mass of your beaker while it's empty. Afterwards, you're going to come to your instructor, and what you're going to do is you're going to receive a scoop of sodium phosphate, okay, Na3PO4. So this is the chemical that you're going to be receiving first. All right, so once you go to your instructor with your beaker, you're going to get a scoop of sodium phosphate. Now, the amount that your instructor gives you is going to be a little bit random. It's going to be about 1 scoop, and so you're going to have to find the mass of sodium phosphate. And that's why it's very important that you found the mass of your beaker before, because what you're going to do is you're going to take this back to the scale, and you're just going to subtract the mass of the beaker from the mass of the beaker and the sodium phosphate inside. That's going to get you the weight of just the sodium phosphate in there. Now, after you found the mass of your sodium phosphate, you're going to receive this 100 milliliter graduated cylinder from your instructor, and this contains copper 2 chloride, and it's going to be aqueous, which means it's dissolved inside of water in this solution. And by solution, I just mean this liquid right here, this blue liquid containing copper 2 chloride, CuCl2. And what you're going to do is first you're going to make sure that you keep in mind in your procedures that this cylinder is going to contain 0.94115 grams of CuCl2. This is going to be your starting mass of CuCl2. Afterwards, you're going to take both of these back to your station, and you're going to carefully pour all of the CuCl2 inside of your graduated cylinder into the beaker. Now make sure you don't pour it really fast. You want to just gradually pour it in there, make sure there's no splashes, and then you can just kind of shake it. Please don't tap it like that. You just want to shake it and just get most of the liquid out. And that should be good. And you're done with the graduated cylinder. And what you're going to do is you're going to return the graduated cylinder back to your instructor. Okay, you don't need to wash it or anything like that. Just return it straight to your instructor. Now, what you're going to do next in this step is you're going to stir your solution. Now, what you're doing is you're mixing your Na3PO4 sodium phosphate with your copper 2 chloride, CuCl2. And so what you're going to do is you're going to stir for about 3 minutes. Now, one thing I do want to keep in mind is that you should not be stirring super vigorously. You shouldn't be tapping the side of the glassware of the beaker. This is something you should not do because, again, that could break your stirring rod. And like I said, if you break the stirring rod or any glassware, you'll get an automatic 0 and bans from future labs. So just very carefully, very slowly. It's okay if it taps a little bit, but you shouldn't be vigorously stirring. You want to just be very careful, and you want to stir it for about 3 minutes. If you want, and to not use the stirring rod a little bit, you could just even give it a shake like this for
some amount of time and then go back to your stirring rod, that's totally fine as well. Some type of mixture of those two stirring methods will be how you stir your solution. Alright, and so the purpose of stirring the solution is so that your two chemicals can mix and react. We started with the two reactants, the two starting chemicals, and by stirring them, we can force them to react a lot faster than they normally would just sitting there.
Okay, so after you stir your solution for 3 minutes, you're going to set up something called a 3F system. The first thing you want to do is you want to go to your instructor and you want to pick up a coffee filter. Just one is fine. Now be very careful with the coffee filter so it doesn't tear. You're only going to get one, and so if this tears, then you're not going to be able to finish up your labs. Just be very careful while you're handling it.
So when you guys get your filter paper, make sure that you guys take this to the scale and that you guys find the mass of your filter paper before moving on and setting up your 3F system.
And then after that, you're going to go back to your station and you should find the other two Fs in the 3F system. So the first F in the system is your coffee filter, and you're going to put it on top of your funnel. That's the second F. And then the third F is going to be your flask. And so you want to set something up like this, where you have your funnel on top of your filter on top of the funnel on top of the flask. And that's going to be your 3F system. And the purpose of the 3F system is to filter out the solid from the aqueous. So if you guys take a look at this solution, we mixed the two starting compounds, right? We mixed the sodium phosphate and the copper 2 chloride. That's on the left side of the chemical equation. And on the right side of the chemical equation, we have some different chemicals. If you guys notice in the chemical reaction, one of them is a solid and one of them is aqueous. Aqueous means that it's dissolved in water. And so we have a chemical dissolved in water in here, but we also have a solid chemical in there as well. And so what we're trying to do now with the 3F system is to separate the solid from the aqueous. So now what we're going to do is we're going to add the solution in the beaker into the 3F system. So what you're going to do is you're just going to carefully hold one side of the filter paper, and then very slowly, you want to give it a swirl before you pour it, very carefully pour the solution into the filter paper. And you want to hold one end of it to make sure it doesn't spill off the edges. And so you want to pour the entire solution into the filter paper, just like that. Alrighty guys, and so this is what it should look like as you're filtering your solution. Now if you guys notice, the solid is getting trapped inside of the filter paper while the water is dripping down. And so what we're doing is we're trapping the solid product inside of the filter paper, and the aqueous product is coming out with the water on the bottom of the 3F system. So the aqueous chemical is going to end up here with the water because it's dissolved in water, and the solid gets trapped in here. Now one thing you guys might notice is that if you look inside the beaker where you mix your solution, there might be some solid products left over. Now we want to make sure we get all of the solid product into the filter, and so what we're going to do is, if you notice some pieces of like the solid product still in there, so if you guys take a look in there, you should still see some stuff in there. What we're going to do is we're going to take it to the sink and just add a little bit of water. Okay, we're going to add a little bit of water to the beaker. Now you don't want to add a lot because it's going to extend the time it takes for you to finish this lab, and we don't want to be here all day, but we're just going to swirl it around, make sure all the water gets trapped inside, or sorry, all the solid gets trapped inside the water, and then we're just going to pour it into the filter. Okay, and that'll allow us to get most, if not all, of the solid into your 3F system. Alright, after you set up your 3F system, you're going to set a timer for 15 minutes, and after 15 minutes, we're going to hope that all of the liquid inside of the filter paper has fallen to the bottom of the 3F system into the flask. So set a timer for 15 minutes, and would be a good time to go to your instructor and pick up your post-lab calculations handout, and you can start doing your stoichiometry for your post-lab. You're going to have to do limiting reagent calculations. You're going to have to draw the picture of the system, and so there's a lot of work to do. And so just make sure during these 15 minutes while your solution is being filtered that you go to your instructor, that you pick up your post-lab calculations and work on it during this time. Alrighty guys, so after 15 minutes have passed, you should see something like this, where there is not much liquid left in your filter paper, and you should see some of the liquid, or most of the liquid,
all the way down in the flask. Okay, so this is what it should look like, and then now you're ready to move on to the last step of the filtering process. Okay, so for the last step of the filtering process, what we're going to do is you're going to bring the entire 3F system to me like this, and then after that, we're going to carefully transfer our filter paper onto the top of this vacuum flask system like that. Okay, and so the purpose of this vacuum flask system is to use a vacuum to forcibly remove all of the liquid from the filter paper. So what we're going to do is we're going to put it on top like this and cover the top so that so that we can create a vacuum so there's no air going in. And so let's bring this a little bit closer and so you can see the top. And then what we're going to do is turn on the vacuum. And then you'll see all of the liquid forcibly get sucked out from your filter paper. And you should see something like that, so that all the liquid is removed. Okay, from there, the filter paper will still be wet. It's not as if all of the moisture is gone, but from there, very simple, you're just going to take your filter paper, and then you're going to take it off of the vacuum, and then you're going to put it on a drying rack. Okay, we're going to move right here. We're going to put it on a drying rack so that it can dry overnight. Okay, and after that, you're just going to get a Post-it. You're going to write your name on it, your team members' names on it, and then you're just going to leave it here overnight to dry, and that's going to end day 1 of the lab. For the cleanup procedures for the lab, pretty simple. All we're going to do is we are going to make sure that we wipe down our lab station. Looks like I had a wet spot, so we're going to wipe that down. And then after that, you're just going to wash the 4 pieces of equipment that you originally found at your lab station. So in the sink, you're going to wash the beaker, you're going to wash your funnel, your flask, and your stirring rod, and then just leave them like so on your lab station, just the way that you found them, okay? So it's basically you're leaving it for the next group. Make sure you guys wash everything, try to get the particles off, and then you're going to leave it on a paper towel on your lab station. It's okay if there's water like this, as long as it's isolated to the paper towel. After that, you're going to get it checked by your instructor, get a stamp for your cleanup, and then that's going to be it for day 1. So after you've let your filter paper dry overnight, you should have something like this. So your filter paper should be completely dry, and you should see the solid product that you made in your lab. Okay, so what we're going to do last is we are going to find the mass of the solid product, and this is super simple. You're just going to find the weight of this, the filter paper plus the solid product. You're going to find the weight of that and subtract the mass of the filter paper that you found earlier, and that's it. You have your actual yield of solid product in this lab. So hopefully that was helpful and gives you an idea of what you're going to be doing in this lab. Let me know if you guys have any questions, and make sure you guys fill out the pre-lab. It's going to be 1 paper per person, and then once you get your pre-lab checked, you guys can start the post-lab, or you guys can start the actual lab. Good luck, guys.